Welcome to class, you guys. So what we have today, we are going to be learning about the triangle, which is an important tool to being able to really understand motion a little bit better. So today's all about, do you know your triangles? This should be a review for you. Make sure you're writing this down in your notebook. The parts of a triangle, the longest side over here is our hypotenuse.
Everybody knows that.
Everybody knows that. Our adjacent side is the side touching the angle that we want to find. So this guy right here, this is the angle we want to find, and it's right next to it, touching it. This is the long side. This is my adjacent side. Hypotenuse, adjacent. If I was to flip this triangle, now I'm trying to find this angle. This becomes my adjacent. My opposite side is the side opposite of the angle. So again, if this is the angle I'm trying to find, opposite side. Angle I'm trying to find, opposite side.
Sweet.
Moving right along. All right, pause the video. I want you to identify the parts of my triangle. And now this is what you should have. So this is the angle that we are given. So this is going to be the opposite. This is right touching the angle that we're given. So that's going to be the adjacent. And then this is the longest side. So that is going to be my hypotenuse. So what do we do with these things? Well, we've got Pythagorean theorem. You guys have seen this before. A squared plus B squared is going to give you C squared. And we can manipulate and solve for certain variables in this equation in order to find, one of the sides. All right, I'm going to bring this down again. All right, so SOA Katoa. Everyone's worst nightmare from algebra, right? I'm going to go ahead and write these over here. So I'm just going to go ahead and write them over here for y'all. Okay, so I've got sine theta equals, and y'all see these little letters up here? SOA Katoa. The O goes with opposite, the H goes with hypotenuse, okay?
I'll bet they know that already.
Yeah, I hope so. We're here. We're at this point, right? Opposite. Actually, let me just go ahead and write O over H.
No, opposite over the
Okay.
yeah.
All right, so I'm going to go ahead and write opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse.
Here you go.
Tangent theta equals opposite over adjacent. Okay.
And that's just like A is equal to B over C, isn't it? If you wanted to solve for one of those.
Yeah, this is just like A is equal to B over C, and I could solve for one of these.
Yeah.
All right, so challenge number 1. Without measuring directly, determine the diagonal distance across your table. Ms. Moore, how do we do this? What does this look like? Go ahead and grab one of my markers over here. Don't! Nailed it. Okay, so here is our table. And we want to know, without using our meter sticks to measure directly, we want to know what this length right here is. So, how do we do this? What do we need to know?
Looks like a triangle to me, Ms. Moore.
It's a triangle for show. So we know that this squared plus this squared is going to give me this squared. So let's do some measurements. I'm going to go ahead and put this guy right here. And right now I'm just measuring this side, the adjacent side of the triangle, because the angle that we are not given, but
We'll get to that in a minute.
okay. Right now I am just measuring.
That's the long side.
The long side, the adjacent side of the triangle. So I need one more. So I'm going to go ahead and add this one here. Okay, so this is 1 meter. So I've got 1 meter, 2 meters, and I'm going to measure all the way to the very end. So I'm going to say 2.1, 2, 1, 2, 3. I'm going to call this 2.13 meters. 2.13 meters. Okay. All right, got that side. Let's do this side. Okay, and notice how I'm measuring it on this part of the table, not the rounded corners. The rounded corners are kind of funky. That's why I'm measuring it a little bit further from the edge. Okay, so this is 1 meter, so our number is gonna be less than 1 meter. I'm gonna call this 0.76 meters. Okay.
It looks like a 3 to me.
Oh. Mistakes happen. I never make mistakes though, right?
That's right.
This pen sucks. Let's get a new one. Okay, so now I'm gonna go back to my Pythagorean theorem. I'm gonna go ahead and write it on the paper for you guys over here. Okay, so we've got a squared plus b squared equals c squared. Okay, I'm gonna go, this is my a, that's my b. So I'm gonna say 2.13 meters squared plus 0.76 meters squared is gonna give me my c squared. So I've got this squared over here. How do I get rid of a square?
I
What
think
should
you
I
take
do?
the square root, Miss Moore.
There it is, baby, okay? We are gonna take the square root over here, which means we have to do the same thing on this side. Boom. Okay, so whatever answer I get by adding and squaring these, I take the square root of that. Let's plug it in. Okay, so square root, I'm gonna say do you think I should put it in parentheses? Oh, it's too late now. Squared plus 0.76 squared. I'm gonna say equals, and I get 2.26. So I'm gonna say C equals 2.26. What are we talking about? Meters. Now, where
Could
does
we
this
check
answer
to
come
see
about?
if that's right? How could we
Absolutely.
check to see if that's right, Miss Moore?
So we think that this is supposed to be the length of my hypotenuse. So let's go ahead and measure it out and see if we're right. Okay, so I'm gonna go ahead and just follow the line here. So that's 1 meter. That's 2 meters. Nice. So 2 meters, 2.1, 2.2, and then we're almost to 6. So we actually almost got 2.26 meters. Sweet.
All right.
Okay, so my last question. It says, what angle does the diagonal side make with the long side? So let me just come over here. I'm gonna go ahead and draw some things on here. I'm gonna write 2.26 meters right here just so you guys can see it. And the question is, what angle does the diagonal side make with the long side? So this is the angle right here that we wanna find. How do we do this? Well, I'm gonna come back up here to the board. So, we are gonna use the two numbers that we measured out, the long side and the opposite side. The adjacent side and the opposite side, okay, tangent. So my question for you guys, I'm gonna rewrite this right here. Tangent theta equals opposite over adjacent. Okay, we want this. How do we get this? So the way that you do this is you're gonna take what's called the inverse tangent. So I'm gonna say theta equals, and I'm gonna take tangent and I'm gonna ignore it over here, I'm gonna put it over here, I'm gonna say tangent -1. Opposite divided by adjacent. Now, I wanna kind of tell you a lie real quick, okay? Just something to help you remember why this is. Whenever we see a tangent right here, this word right here, tangent, I'll just call it tangent like that, okay? If I have tangent on this side, and it's kind of like there's multiplication going on here, if I wanted to get rid of something that was being multiplied, I would divide, right?
Yeah.
So it would be like saying 1 over tangent, 1 over tangent. Now, 1 over tangent, we can write this another way, right? We can write it like this.
Yep.
So this is not true. Let me be very clear. This is not mathematically how it works. But this is what helps me remember how to do this. If I've got tangent over here and I want to get rid of it because I'm trying to find this, I can just put the tangent -1 on this side to kind of cancel it out. But again, this is not correct math. So we're going to take this equation. Let's go over here and write that over there to figure out the angle. Okay, I'm gonna write it right here for you guys. Okay, so we said that theta equals tangent -1 opposite over adjacent. I'm gonna put those in parentheses for you guys.
Which one's the opposite side?
Good question. If this is my angle, my opposite side is this one.
And how much is that?
0.76 meters. So I'm going to say tangent -1, 0.76 meters divided by my adjacent, the long side, 2.13 meters. Boom. Calculator, I got you right here. Okay, so hopefully you have a tangent -1 button. Mine's right here, tangent -1. I'm going to say 0.76 divided by 2.13 equals, and I get 19.64.
Wow.
Degrees. Oh, okay, here we go. All right, so there we go. All right, so here we go. So here is we've lined this guy up, and you can see that it's just about, this is 20 right here, it's just about at 19. Sweet, okay. All right, so what did we just do? We have just added 2 vectors.
Woohoo!
Whoop, whoop, whoop.
What's a vector, Miss Moore?
I'm glad you asked. So vector quantities have both magnitude and direction. So we just got our magnitudes. Have we got our direction yet? Scalar quantities have magnitude only. When we are talking about the triangles that we just did right there, those are going to be vectors. So we still have to talk about direction. We've got our magnitude.
We'll get to that in a minute.
Okay. All right, so vectors are graphically represented with arrows. In a vector diagram, a vector arrow may be moved around, but its length and direction must stay fixed.
Can we have arrows over here, Miss Moore?
Yes, I want to show those. So, where would my arrows be here? Well, I could draw a line. This would be one of my vectors. Okay, and this would be another one of my vectors. So those are my vectors, graphically represented by arrows. And, oopsies. Oh, go back. Let's talk about something called vector addition. So vectors are added head to tail as an answer called a resultant.
There you go.
All right, so what does that mean? So here's my first vector, here's the tail, here's the head, okay? So we added these head to tail, okay? The head of this arrow is attached to the tail of this arrow. And it says the answer is called the resultant. So this vector added head to tail to this vector gives us this one. We call this the resultant. I'll just go ahead and label it here for you guys. This is the resultant.
Okay.
The resultant is drawn from the tail of the first vector to the head of the last. What does that look like, Miss Moore? Okay, so here is the tail of the first vector, okay? So right here, boom, to the head of the last, okay? The head of the last is over here. So I draw this arrow like this. That is my resultant vector.
Sweet.
Direction of a vector depends on its reference frame. So we want to talk about the x and y axis. We need to think about the vertical component and the horizontal component. Or maybe we have to think about it in terms of north, which is that away, south, east, or west. Or lastly, we might have to think about it as points on a compass. And my students who took physics last year will recognize this guy, my navigator's protractor. And so I want to actually, we'll put that up on the next screen here. Okay, so basically that is this. Check out this red line. Well, actually first, let's take a look at this. We've got north, east, south, west. And you guys are familiar with those terms. What those really, hopefully, what those really
Well, that's
mean,
for a map, and you see it on a map, yeah.
So what we really mean is at north is represented by 0 degrees. Exactly opposite of that is south, which is 180 degrees in the opposite direction. This right here is 90 degrees, and then so 90, 180, 270, and then we go back to 0. So making a total of 360.
Oh, wait a minute. But it says 0. How can it be 360?
So we go 90 plus 90 plus 90 plus 90.
Aha. Okay, so it could be 360, but we call it 0.
We call it. Right, so this red line, what would you call that? If I asked you what direction it was going,
Oh,
in,
that
what
must
would
be
you say?
northeast. It's between north and east. It must be northeast.
Okay, so you bring up a good point. Yes, it is between north and east, but is it exactly in the middle? I know how we can figure out if this is northeast or not. Let's go ahead and put this. This is 0. I'm gonna put it right there. Line it up in the middle there. Okay, and this is 55 degrees.
Yes, it is.
So not northeast. Okay. All right. So back to our resultant. The resultant represents the sum of all the vectors. It is the addition of our vectors. The resultant is this one, the long side plus the short side on the triangle that we measured on the table. It is the single vector that can replace 2 or more vectors. And when I say more, I mean we could be adding 3, 4, 5, 10 vectors. Now, we're not going to get into that.
But we could.
We could if we wanted to, but we are not going to get into that.
If you're bad students, we'll make you.
Okay, so in this course, we are only going to be doing 90-degree vector triangles. This allows us to use Thag's theorem and SOHCAHTOA to find the magnitude and the direction of the resultant. So please write these down in your notebook. Step 1, sketch a vector diagram. Step 2, we're going to use Thag's theorem to find the magnitude of the resultant. Now, remember on the table triangle, we used Pythagorean's theorem over here to find the magnitude of our resultant. Step 3, use the inverse tangent function to find the angle. We did that over here. Inverse tangent to find the angle. And we said it was 19.64 degrees. And then resolve to reference direction. This right here is going to be the trickiest part. Do not let it scare you. Let's do it. Add these two vectors. Before I do this, I'm gonna set my reference frame. So I'm gonna go ahead and draw north, east, south, west, 0 degrees, 90 degrees, 180 degrees, and then 270 degrees. Okay. All right, so it says add these vectors. 4.5 kilometers at 270 degrees. So 270 is this direction. You can see 270 there. I'm going to go ahead and write that right here. Okay, so I'm going to say 4.5 kilometers at 270 degrees. And it's really important that you write down all the numbers, the units, and the degrees. The next one, it says plus, again, we're adding vectors here, plus 6.4 kilometers at 180 degrees. Okay. look
How,
back at
how do
my
you
compass.
add arrows? I forgot.
Okay, so we know, so when we add our vectors, we add head to tail. So we are gonna put our tail wherever the head of this arrow is. Now, what direction are we going? Well, it says 180. That is this direction. So I'm gonna go ahead and draw this. 6.4 is a little longer than 4.5, so I'm gonna make it a little bit longer. Not to scale, that's okay. Again, 6.4 kilometers at 180. You guys can see how important the direction is here. Okay, so we added this head to tail. The resultant. So I want to add these vectors, when I add the vectors, I'm going to get my resultant. We start from the tail of the first one and we go to the head of the last one. So I'm going to draw my resultant with a dotted line right there. Can we figure this out? How do we do this? Step one, we've drawn our sketch. Now we're going to do Pythagorean's theorem. Perfect. I'm going to put this down. Now we're going to use Pythagorean's theorem. So to find the magnitude of the resultant. So here we go. So I'm gonna say I'm gonna call this, messing up here, A, B, and C, right? I'm gonna say A squared plus B squared equals C squared. So I'm gonna say 4.5 kilometers squared plus 6.4 kilometers squared equals C squared. Before I do this, what did I have to do again to get rid of the square? Square root. Square root. Grab one of my handy dandy. All right, here we go. Let me see if I can find the square root sign on here. There it is, right there. Okay, so square root of 4.5 squared plus 6.4 squared equals, and I get, can you see that right? I get 7.82 bombs away. 7.82, and we're talking about kilometers here, equals my C. So that is the magnitude of my resultant. That's this part right here. That's my C. I'll leave that right there. 7.82 kilometers.
Go.
Step 3, we're gonna use the inverse tangent to find the angle. What angle do we use, Ms. Moore? Well, we're always going to think about, where we're starting at. So if we're standing right here, we're starting right here, okay? We're walking this way, we're adding the vectors together. We want to use this angle right here, okay? So here's my angle right there, and I want to use inverse tangent. I'm gonna go ahead and do it. Actually, yeah, I'll do it right up here. Okay, so we know that tangent of theta equals opposite over adjacent. To get rid of tangent on this side and just get this, all I do is tangent -1, opposite over adjacent. Okay, and let's go ahead and plug in our numbers. Our opposite, if this is my angle right here, my opposite is going to be this one, so 6.4 kilometers. Actually, I don't need to put those units in there.
Squared. Oh, no, I beg your pardon.
Okay.
We're not doing thanks to I never make mistakes either.
So 6.4 kilometers squared, and then my adjacent, the one that's right next to it, touching it, is 4.5. Okay, let's plug this into my calculator. So tangent -1, 6.4 divided by 4. Okay, let me do that again. Tangent 6.4 divided by 4.5, and I get 54.89 degrees. Okay, we have our angle right here, but we have to think about our reference, the reference direction. So I'm gonna go ahead and draw where this guy is. Oh, thank you. Okay, I'm gonna go ahead and write this number in here. So 54.89 degrees. Okay, all right, so we are talking about this and this part right here. Okay, we're thinking about this quadrant right here. So this resultant is 54.89 degrees right here. Can you see that okay with this?
I can, yes.
Okay. All right, so we can't just say, well, let's write our magnitude down first. So our final answer is going to go in this lovely box we have here. And we said that C was 7.82 kilometers, but we don't know what the degrees are. Let's figure this out. We cannot just put 54.89 because that would be somewhere over here. So this is 270. Could I do 270 minus 54.89 to figure this out?
Yes, you could.
Okay, I'm going to go ahead and write that in here. 270 minus 54.89 equals 215.11. Okay, so the answer to this problem was the question again. Let's take a look at this. Okay, it just wanted us to add these two vectors. It's a vector, so it has magnitude and direction. We have our magnitude, we have our direction of our resultant vector.